And I'm live. Yes. And we're live once again. Oh, here we are. Back in the fray. Let me check something online here. Okay. I'm just looking to see who did it. Yeah. You guys obviously have an edge elastic assignment that is due today. It's not due till 2 o'clock, obviously, but I did assign that many days ago. But it looks like only 2 of you have gotten it done so far. Completely done. That's according to Google Classroom. I got to check Edge Elastic first to see who did what now. As you guys are joining, I want to just give you an idea as to what this week and next week is going to look like. First of all, I have you today and I have you Friday. Today is the day that we will begin reviewing for said midterm examination. I have a PDF that I'm going to input into the Google Classroom live stream. In fact, I'm going to get that ready right now as I am talking to you. Don't cancel that. Add the link from Google Classroom. Recent Algebra 2 midterm review. Let me just double check that this is the right one. There it is. Yes. I'm going to post that in a few minutes after I do my introduction. So, yes, all these people saying hello here. Next week, period 3B. Your midterm examination is not until Thursday the 28th, which means I have you today and I have you Friday to review, but then your midterm will be the 4th day of midterms. That Friday, the 29th, from what they've told me, that Friday the 29th should be an A day, so I will not see you again on that Friday. Who the heck knows? I've heard a lot of different stories about what's going to happen on that Friday. I've also heard a lot of different stories as to what's going to happen next week. Supposedly next week, you all will be joining me back in here, or except for the virtual kids or whatever. But the numbers in New Jersey have not improved over the past 2 weeks. I don't know. Are they going to extend it another week? Who the heck knows? But regardless of if that happens, if you're in class or if you're online, the midterm will be taken. There'll be an assignment posted on Google Classroom that will be only available during that particular time frame, in which people will access the midterm and answer those questions and take a picture of their work and submit them to me and all that fun stuff. We'll have to be on a Google Meet for that next week. Whether it's people in here and at home or all at home, I don't know. See what happens. Okay. Here's what I'm going to do. I'm going to post the PDF of the review to your Google Classroom stream. And then I am going to begin reviewing those questions. So post. There it is. In your Google Classroom stream, there should be the post of the midterm review that I'm going to begin working on. Now, while I am going over these questions, if you do have questions of your own that you would like to ask, by all means, ask them, and I will talk about them with you. I do have the stream open right here. I'll show you. Hold on. Once it gets loaded. There it is. See, look. There I am, a few seconds behind, and I can see all your comments right there. So if you do have questions, please, by all means, please make sure you're asking them. But I would like to begin reviewing. So have your calculators ready. In terms of what you should be doing during this time. During this time, I am going to be answering a ton of questions. You should be writing down whatever you feel is important and necessary to get today done. I'm not going to tell you whether it is or it isn't. Just that whatever I'm covering is fair game. A lot of this stuff I am going to put on a separate sheet of paper so that I have the room to do it. And like I said, if you can't read the screen, the PDF was just posted into the Google Classroom. So let's see. Number 1, your teacher told you to write an equation of a parabola that has a vertex of -2, 3, contains the point 0, 1, and opens up. You're having trouble with the problem. Wah, wah. Explain why. Now, in order to explain why, I'm going to get some paper over here. Let's see what we can do with this. Now, your teacher said that the parabola should have a vertex of -2, 3. Now, if you happen to remember what a vertex actually is, a vertex is actually the most extreme point on the graph. The vertex is either the highest point or the lowest point, depending on the direction that the parabola is opening. So your teacher told you to write an equation of parabola that has the vertex of -2, 3 and contains the point 0, -1. Right there. The problem is, the reason you're having trouble is because your teacher told you that the parabola should open up. But if this point that I'm pointing to is the vertex, there's no possible way that that can happen. If that's the vertex and it opens up, then the vertex should be the minimum point. But there seems to be a point existing below the vertex. That's why you can't do it. Part A. Number 1, part B, how would you change the problem? Now, there's a number of different ways to change the problem. You could move the vertex to the lowest point. You could move that extra point 0, -1 and move it somewhere above the vertex. But the easiest way of doing this problem, the absolute easiest way of doing this problem, is by changing the simplest thing. Instead of saying it opens up, say that it opens down. And now everything is fixed. So part A, you're having trouble with the problem. Why? Because, well, if it opens up from the vertex, it can't go through 0, -1. How would you change the problem? Make it open down. Then make the change and complete the problem. This is where we begin. For this problem, you're going to need the following equation. This is something that we did much earlier in the school year. Not sure quite exactly when we did this. But I just saw a comment from Johnny Beasley's videos. That's funny. Anyway, we saw this much earlier in the school year. And this is H and K. H and K are the vertex. Now, in the past, H and K determined a horizontal and vertical shift. H and K determined the starting point of a square root function. Yes, it did all those things. It also determines the vertex of a quadratic. So, the way that I'm going to write this, since the vertex is at -2, 3, I'm going to start by rewriting this equation like this. I'm going to put the 3 in for the K, plus 3, because it's -2, 3 for my vertex. But it's supposed to be x minus h. That's why I left it blank for a moment. X minus h is supposed to be x minus -2. And because it's x minus -2, the minus the negative makes it a +2. Now, we're not done yet. We are not done yet. But that is the first step towards properly writing this problem. Now, I need to figure out what the a value is. Since this parabola is supposed to open down like this, since it's supposed to open down, that A value better be a negative number. But is it -1? Is it -5? Is it -0.5? I don't know. But there is a way to figure that out. Instead of guessing, take the 0, -1 and plug it in for x and y. If you were to do that and then solve for the remaining A value, move that over just a tiny bit, there we go, and solve for the remaining A value, then you can figure out exactly what A is supposed to be. Now, yes, A is supposed to be a negative number, but which negative number? This will prove it beyond the shadow of a doubt. I'm going to do two things. I'm going to simplify what's inside those parentheses and square it, and I'm going to subtract the 3 from both sides. This will give me -4 equals 4a. Because, well, 0 plus 2 is 2, and 2 squared is 4. This proves that the a value has to be -1. As a result, well, y equals -1, parentheses, x plus 2 squared plus 3. That is the answer to that question. Again, for those of you that just joined, the problems that I'm going over are problems off of a midterm review that I just posted to the Google Classroom stream. I strongly suggest that you have it open and that you have those notebooks to possibly write down some extra information that you may need to know in order to get these problems done. Make the change you suggested in Part B and complete the problem. There it is. Instead of opening up, I say it should open down. It has that vertex, -2, 3, and it goes through the point 0, -1. Huzzah! Let's look at number 2. Now for number 2, I'm just going to move this paper. Zooming in, zooming in, zooming in. Again, if you're having trouble reading this, the PDF is available in Google Classroom Stream. A box has the following dimensions: x plus 3, x minus 2, x minus 4. They want you to write a function for the volume of the box. Okay. Now, look at part B for a second, though. Use a graphing calculator to graph for -10x to +10. That part's not so much important, the -10 to 10 thing, because every calculator is automatically set to -10 to 10. But I'm going to show you how to do this a lot easier on Desmos, because the graphing calculator is one thing, but Desmos is much easier to deal with. Let's do part A, though. Write a function for the volume of a box. Okay. Volume of a box, length times width times height. Length, I'm just writing it down from the paper, times width times height. It should look something like this. And it does. Okay. So what do I do? You're going to have to multiply all those things together. All right. Let's multiply the first two. You could do FOIL with the first two. But in my opinion, it is a lot easier to multiply using this box. It's a lot easier. Multiply in the box like a lattice. X times x is x squared. 3 times x is 3x. -2 times x is -2x. And down here you get a -6. Let's combine some like terms. X squared plus x minus 6. Okay. But I'm still going to have to multiply by x minus 4. Now, unfortunately, FOIL doesn't really work here. Unfortunately. It's just one of those things. I don't know. So, My opinion, it would be 1,000 times easier if you did this. Create another box. But this time, make it a 2 by 3. X -4, x squared, x -6. If you set up that box, it'd be a lot easier than trying to do anything else. Just remember your exponent properties when you are multiplying. X cubed, x squared, -6x, -4x squared, -4x, +24. Combine like terms. X cubed minus 3x squared minus 10x plus 24. There is the volume function that they wanted in number 2, part A. You're going to have to do this carefully. Very carefully. Multiply the first two together, make a 2 by 2 box if you want to. You could do FOIL. But then when you do the second multiplication, you could do a distribution method if that's what you were taught, or another box. I like the box. But if you have a better method for it, then by all means, just make sure you can show that work. Okay. Let's take a look at what they're asking me to do next. They want me in part B to graph that thing. I am going to show you Desmos. Desmos. In Desmos, it is 1,000 times easier to graph this thing. F of x equals x to the third minus 3x squared minus 10x plus 24. Now, if you notice, this is the same issue that you would have on the graphing calculator as well. The fact that that top part of the graph would be cut off. So what you're going to have to do is kind of scroll out and back up. There we go. Just trying to center it as best as possible. That's pretty good. Awesome. And I would screenshot that and put that into whatever thing I was going to be turning in. What's the next part say? The next part wants you to look at the graph and identify any local maxes or mins. All right. Let's take a look at these local maxes and mins. Now I'm going to estimate. I'm going to estimate based on what I see up here. Well, this looks like a local max, and it looks like it's at -1. Yeah, I'll write it over here. -1, 30. That's what it kind of looks like. Down here, it looks like a local min. And that local min looks like it's at 3, -6. Local mins and maxes are basically where are the turning points? Where are the turning points? And it's just easy to identify them as like peaks and valleys. But the question on the review says to look back at your graph, identify any local max and mins, and then do these values represent max and min possible volumes? Oh. Do they represent possible volumes? Well, bit of an issue with that. The issue that I have with that is that these are the dimensions of the box, length, width, and height. And if you plugged that -1 into either of these, if you plug that -1 into either of these, you would have a negative length on your box, which does not make sense. Furthermore, if you plugged in a 3, you would end up with a negative volume, which cannot happen. You can't have a negative length after you plug the number in, and you can't have a negative volume after the calculation's done. So again, going to the question on the review itself, it said, do these values represent max and min possible volumes? No. Explain. I just did. If you take that -1 and try to plug it in, you get a negative length on the box. Can't do it. If you try to use the 3, well, technically, if you use that 3, it'll also get you a negative length on the box, but it will also get you a negative volume, which can't happen. So goodbye, those numbers. But now, look at number 2, part E. If the volume of the box is 72 cubic feet, what will the dimensions be? This is the big, big problem that we're going to be facing today. I mean, yeah, we're going to be doing other problems after this one, but this is the big problem that we're going to be facing today. Number 2, part E. Let's see. Click. I got to write down some of this information. Now, they want to know, what will the dimensions of the box be if the volume is 72 cubic feet? I'm going to take the equation that we found in the previous part, and I am going to set it equal to 72 . This is what we have to solve. This is the big problem. Now, this is going to take you back. This is going to take you back a bit to like October, November. We have to solve this problem. I have to eventually figure out what the value of x is. It's a cubic. I can't like do like the Tucker method of factoring or anything like that. Oh, wait, there was a thing that we did with solving higher level polynomials. Oh, I seem to remember needing one side equal to 0. I need to get one side of this problem equal to 0. So I'm going to subtract the 72 from both sides of this problem. And let's see, that should be minus 48. Yeah, and it is. That's what I have to solve. Now, I seem to remember when we solved problems like this, we used a synthetic division bar, because using that synthetic bar was the easiest way to determine, number 1, whether or not a number worked, and number 2, if it worked, if the resulting equation would produce more answers. So what we need to do is we need to go to a graphing calculator with that equation, the one that is equal to 0. So I'm going to go to my graphing calculator. I'm going to go to my y equals key. Oh, man, it's already there. It's because I did this yesterday. So anyway, I plug this thing into the graphing calculator and I hit graph, because I'm trying to visually identify any zeros of the function. If I can find those zeros of the function, then I can try to divide them out using synthetic division. Now, when I graph it, I see a single line. Ugh. but that single line crosses the x-axis at +6. This is incredibly helpful because knowing that it crosses at +6, goodness gracious, I think this will work. Now, if you happen to remember synthetic division, we're trying to get a remainder of 0. Let's see if we can get it. You put the coefficients where they belong. As a reminder, synthetic division is nothing more than repeated addition and multiplication. 1 plus nothing, multiply by 6, add, multiply, add, multiply, add. I got it. Now, what we have just done is we have proven that 6 is indeed a 0 of the function. We got a remainder of 0 and then a bunch of numbers. Now, my big question is, are there any other answers? I don't know. Are there? Ooh. In order to determine if there are any other answers, we're going to have to take the resulting numbers that we got from the synthetic bar and do something with them. Because if you happen to remember remainder, constant, x squared, the resulting equation is actually, separate this stuff, it's actually an x squared plus 3x plus 8. That is the resulting equation. Now, we already have an answer of 6, but I need to see, are there any other answers? I need to solve that quadratic. Now, what I would like to do is I'd like to throw it into the quad formula because I can't factor it. But within the quad formula, I am going to check the discriminant, b squared minus 4ac, because the discriminant went into the square root in the quadratic. And if that discriminant is a negative number, then I know that there are no more real solutions. Let's see what happens. 3 squared minus 4 times 1 times 8 should give you 9 minus 32. 9 minus 32. Oh, which is like negative 23. Ugh. No more real solutions. No more real solutions. Which means 6 is my only possible real solution. Now, I am not done with this problem. But I am well on my way. Kelsey, I just saw your comment. I have not heard back from anyone just yet. I do apologize for that. I mean, why am I apologizing? It's really, it's IT, you know. But if I don't hear back from them today, I'm going to have to actually physically go down there to their department and just kind of verbally say, hey, what's going on? You know, that kind of thing. So we'll see. Okay, back to me. Where'd that thing go? There we go. Now we do. Oh, that's where I just went. Of course, yes, you do. I know. I want you to be prepared as well. You know. I know it's IT though. Thankfully, our midterm is the last midterm, so we do have a little extra time. I do have an answer of 6, but I need to figure out the dimensions. As a reminder, the dimensions of this thing were x plus 3, x minus 2, and x minus 4. So I'm going to take that 6 and I'm going to plug it in for x, and I get 9 feet by 4 feet by 2 feet. Those are the dimensions of this box. It's a very involved problem. Let me just recap exactly what we did based on the way the problem was worded. If you go to the review, it says a box has those dimensions. Write a function for the volume of the box. So we took those dimensions and we multiplied all three together. It says to use a graphing calculator to graph it. I suggest Desmos. It's better than the graphing calculator for graphing, that is. Then, looking at the graph, identify any local mins and maxes. We did, and we approximated what they were. Do these values represent max and min possible values of the box? No, they didn't, because they produced either negative side lengths or negative volume. If the volume is 72, what will the dimensions be? So, the big problem of the day, we set our equation equal to 72, got it equal to 0, looked at the graph, determined that 6 is a possible 0, divided it out using synthetic division, checked the resulting equation to see if it produced any more answers. It didn't because of a negative discriminant, and then plugged our one and only answer into those dimensions to get 9 feet by 4 feet by 2 feet. I love that problem. But of course, there are not many problems that I don't already love. Ha 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 ha. Now, number 3, again on the review, number 3 has a bit of an issue with it. I did not write these problems. Number 3 has a small issue with it, which no one has been able to give me an answer in terms of correcting it. So I had to make up my own rationale for it. What that problem is, you're not going to find out until we actually get one of the answers. So let's look at number 3. A rocket follows the following path, which is an equation. The variable t represents time, and h of t represents the height. To graph, use that. I don't really care for that. I'm not going to do that. In fact, I don't even actually have to graph it. If you look at the questions, A, B, and C, none of them ask you to graph it. That's not the issue. That's not the problem that I had with it. Part A. When will the rocket hit the ground? Or when will the rocket reach a height of 0 feet? Now, here's the interesting thing about this equation. The really interesting thing. Let me zoom in on this equation right here. And this kind of leads itself to my issues with the problem. T represents time, and the height is measured in meters. If you plug in a 0, meaning 0 seconds, if you plug in a 0 for t, meaning the rocket has not launched yet, what you're going to get is something like this. You're going to get h of 0 equals negative 97.5. Now, what that tells me is that at 0 seconds, when this rocket has not launched yet, bear with me, it's 97.5 meters underground. This is the problem that I had with this thing. And it's going to be reflected in the answer that's given in a few minutes. But think about this. Looking at this equation, if you plug in 0 for t, meaning 0 seconds, meaning the rocket has not launched yet, that means that the rocket is negative 97.5 meters in height, meaning 97.5 meters below the ground. Okay, is this one of those things like the U.S. Army where they have like rockets like under the ground and then they kind of in like missile silos or some junk like that? Maybe. That's the only way I can reconcile the answer that we're going to get. Because this rocket is not going very far. Part A. When will the rocket hit the ground? This is where it kind of gets a bit interesting for me. I'm going to write down that equation. Zoom back out. I'm going to write down that equation. H of t equals negative 9.4 t squared plus 49t minus 97.5. I did this problem with my A-Day Algebra 2, and I just was dumbfounded at first. I'm just like, what is going on with this problem? And then I realized, like, whoever the heck wrote this problem didn't really think through the answers. They really didn't. And I can't talk to them because they're not here today. When will the rocket hit the ground? Okay. When the rocket hits the ground or reaches a height of 0 meters, you have to do this to the equation. And then we have to solve it. Unfortunately, you can't factor it. And you're not going to be able to use synthetic. The only thing we have to rely on is everybody's favorite, the quadratic formula. Negative b plus or minus b, the square root of b squared minus 4ac, the whole thing over 2a. That's what you need. So I'm going to calculate the discriminant separately to make my life a lot easier. I'm going to calculate that discriminant separately. 49 squared minus 4 times negative 4.9 times negative 97.5. Ugh, what a terrible calculation. Let me type this thing in. 49 squared minus 4 times negative 4.9 times negative 97.5. Oh, that's kind of nice. Gives you 490 right on the dot. Okay, let's use this quad formula. All right. Negative 49 plus or minus the square root of 490. The whole thing is over 2 times a, or 2 times negative 4.9. Now, it would be easier if I just did this. 2 times negative 4.9 is negative 9.8. It'll make my life a lot easier. Now, in the calculator, I'm going to show you this on my computer in a moment. But in the calculator, I'm going to have to do this calculation twice. Once with plus and once with minus. So let's actually do that. Parentheses. Negative 49 plus the square root of 490. Now, in your calculator, if you notice, there's a little arrow key there. That little arrow up there, you need to tab over. Otherwise, you're going to keep typing underneath the square root. By doing that, you can now include a parenthesis. Divided by negative 9.8. By doing that, that just makes 1,000 times easier. So now I'm going to do this calculation twice. I'm going to do this calculation once with plus. Then I'm going to bring the equation back so I can change it to a minus. There's the calculation done first with plus. If you hit second enter, it brings the problem back for you to edit. Second enter will bring it back, and all you have to do is change that plus sign to a minus sign. minus. Now, here's the issue that I'm having. And this is the issue that I was kind of like, what? In regards to class yesterday. I got two answers. Yes, I expected two answers. But both of those answers are positive numbers. And both of those answers technically could work for the rocket hitting the ground. But remember what I said about the equation and the fact that this rocket is 97.5 meters below the ground? That's the only way that you can reconcile this problem. It takes about 2.74 seconds for the rocket to reach the ground from underground. And then it goes up, and then at 7.26 seconds, it comes into the ground. This is a terrible rocket. A terrible rocket. A rocket that doesn't deserve to be a rocket. But technically, I mean, I guess the answer is 7.26 seconds. Sometimes these problems make me cringe because it's like people throw them together without thinking about the consequences of the answers and whether or not they make sense in context. Again, this is the only way I can reconcile it. Then the question wanted to go a bit deeper. Then the question, I'm going to zoom in on this. How high will the rocket be at 3 seconds? And what is the maximum height of the rocket? Again, we're going to have to deep dive this thing. If I want to know how high will the rocket be after 3 seconds, that's actually a very straightforward problem. The reason why it's a straightforward problem, I realize I'm going to have to zoom out. There we go. The reason why it's a straightforward problem is because all you have to do is plug 3 into the equation whenever you see a t. And then you can just go straight to your graphing calculator or whatever you do to calculate that thing, type it in and see what happens. Now, keep in mind that this rocket better have a positive height because 3 seconds exists between the two previous answers. Let's see if this works. 49 times 3 minus 97.5. Boom. This rocket will reach a height of 5.4 meters 3 seconds after launch. Just a matter of plugging them in. But then the next question is saying, what is the maximum height of the rocket? To get that maximum height, you're going to need to remember the formula, negative b over 2a. Negative b over 2a determines part of the vertex. In fact, it determines the x value, or in this example, the t value of the vertex. Let's figure that out and see how far we can go with this. If you're going to figure out that vertex, you got negative b over 2 times a. It would make my life a lot easier to just change that to a negative 9.8 on the bottom. So I can just do 49 divided by 9.8 and get 5 right on the dot. But keep in mind that that 5 is not the highest height. It is the time it takes to reach the highest height. It will reach the highest height after 5 seconds in the air. What is the maximum height? Well, you're going to have to take that 5 and plug it back into the equation. Let's see what it gets us. Negative 4.9 times 25 plus 49 times 5 minus 97.5. Ba-bow! I get 25 right on the dot. 25 meters. Yes. Excellent. I just got a text message from a colleague that said that Pinelands just went virtual again. That's interesting. I don't know if that's going to have any consequences on us. Oh, and Southern. What's the wording here? Southern is going hybrid. Okay. We'll see if that changes. If you guys happen to remember the previous times that our school shut down for any amount of time this school year, it was all last minute stuff. End of November? End of November, they made the decision on a Sunday afternoon? They made the decision on a Sunday afternoon. And then when they decided to go virtual for these 2 weeks, they decided it on a Friday afternoon. The key is nobody knows what's going on. But I'm just letting you know what a colleague of mine just texted me. Pinelands just went virtual again. Southern going hybrid next week. Okay, back to this. Oh, goodness gracious. Okay. Here's what I would like to kind of play out for you guys. I am just going to give you a brief preview as to what the rest of this review is going to look like, so that you know what Friday or what kind of questions you should have in mind come this Friday. Kelsey, we are quote unquote scheduled to come back on Monday to begin midterms. We'll see how that goes. Anyway, if you look at number 4 on the review. Now, I'm not going to actually do these problems right now. What I would like to do is I would just like to kind of gloss over some of these and then do them in full on Friday. But number 4 is a lot of the same of what we're doing. Number 4 is saying find the value of the discriminant. We've done that. Describe the number and type of roots. Well, yeah, depending on if it's positive or negative or 0. Find the vertex. The vertex is either the maximum or the minimum, negative b over 2a. And find the exact solutions using the quad formula. We've done that as well. I'm just trying to show you what you have in store for the rest of this review and what you need to be studying and focusing on in preparation for this midterm. Now, opening up this review, going to the next page. Again, I just want to show you because we've done a lot of these things today, and we are going to go over these problems in full on Friday. What I would suggest that you do is that between now and Friday, you give some of these problems a shot and see if you can't do them on your own. And then on Friday, I will be able to go over it and you're going to be like, oh, yeah, that thing. I did that thing right. Yay, good for me. And then you high five yourself. On this part that says multiple choice, practice, even though there is no multiple choice. Again, I didn't make this. What is the remainder? If you divide those, that's synthetic division. What are the x-intercepts? That could be factoring or that could be quad formula. Graph that? Oh, yeah, we've done stuff like that. You don't have to multiply those back out. I can show you exactly what's in store for that one. Pretty much you're going to be using a graphing calculator and utilizing the table of values. What are the solutions to that thing? Well, it's already factored. You set the individual terms equal to 0 and then solve. This is the dumbest question in the world almost, but look at number 5. Where will a graph of a parabola cross the x-axis if it has zeros of 4 and -2? It will cross at 4 and -2. Correct. I mean, if you want to get detailed about it, you could be like, oh, +4, 0 and -2, 0. Why would they put this on the review? Number 6 is talking about a composition. Again, I'm going to go over that in full detail with you on Friday. And then they talk about some of these other things, inverses, domain and range, where the square root moves, a small rocket, another box problem. I'll zoom out a little. Simplifying these expressions, factoring. You know what? Maybe I will do that factoring one with you before we leave here today. Let me just double check what it looks like. Because depending on what it looks like may change what I'm about to do here. Ooh, interesting. Yeah, that's terrible. I'm just trying to see where this thing actually crosses the x-axis. Ooh, interesting. Yeah, I'm going to have to save that problem. I will definitely save that problem for a little bit on Friday. I'm just double checking one extra little thing. Oh, it's going to give me a terrible answer, isn't it? Yep, yes, it will. Okay. And then on the other side, the path of a ball in the air. How high did it go? At what times did the ball reach 60 feet? This is stuff that we've done today already. So like I said, between now and Friday, take the time to kind of go through certain problems on this review. And then on Friday, we are going to attack this thing head on and get done, well, within reason, everything that we can. As for you right now also, I'm going to remind you that you do have a major on Edge Elastic due for me. Keep in mind, I got an email. I wasn't able to reply to the email in regards to the Edge Elastic thing, but the email was asking about like submitting it, I think, or something along those lines. Keep in mind, whatever you end up submitting on Edge Elastic, I will check Edge Elastic first. I have to check Edge Elastic first because there are certain things that I may or may not have to adjust on Edge Elastic because some people type in an answer that is correct, but because Edge Elastic doesn't like the way that it's typed in, I have to adjust the score manually. So I check Edge Elastic first, then I update Google Classroom, then I throw everything into Genesis. Was there an issue with the Edge Elastic major, Kelsey? I mean, like issue with like problems loading or whatnot, or was it like what the questions were asking? Because if it was in regards to the questions themselves or any issues like that, you can email me and I can determine whether or not I want to clarify. Simply because I don't want to give anything away on a live stream or something like that. So I'm going to say with whatever. Okay. Email me if you need clarification as to what it is asking. I think that would be the simplest way of going about it. Because there's a little bit of a weird delay on the live stream where it's like I ask a question, then I pause for like a minute waiting for you to type something in. But if you emailed me, we could knock that thing out pretty quickly. But again, I'm not giving away answers. I can clarify what the question is actually asking. So please do that, and I can definitely get back to you before the end of the workday. No, wait, workday. I can get it done probably before the end of my lunch. Who am I kidding? Yeah, I could definitely get it done before the end of my lunch. So in the meantime, if any of you have any questions for me, please make sure you are emailing me. Otherwise, if you have not left a comment in the chat, please make sure that you do. And I am going to dismiss you from here. So, okay. Bye-bye. Bye-bye. Everyone, goodbye. Bye-bye. Bye-bye. You can leave now. Bye-bye. Bye-bye. Bye-bye.